Hi, and welcome back to another episode of Rachel Teaches Math. Today we are going to be covering characteristics of quadratic equations in factored form. Okay, so where I want to start is what information are we getting from the factored form of a quadratic equation? Well, the most important thing that we're getting is where it crosses the x-axis. So what we're going to do first is set each of the binomials equal to 0 and solve for x. So my first one, x minus 1 equals 0, and then we're going to do x plus 3 equals 0. So if I add 1 to both sides here, then I get that x equals 1. And that's literally telling you that your first x-intercept is at 1. The next one, I'm going to subtract 3 from both sides, and then I'm going to have x equals negative 3. That's telling me that my other x-intercept is at negative 3. So I know my function is going to cross at these two spots. So probably the next easiest thing to figure out is where your line of symmetry is. Well, if these are your intercepts, your line of symmetry is right down the middle. So I'm going to just start by drawing my line of symmetry in. And that is at x equals negative 1. I know my vertex has to be somewhere along this line, maybe somewhere down here. I need to figure out what is the y value when x equals negative 1 if it's on this line. So I'm going to take my original equation and say y equals. Now my x value, my line of symmetry is negative 1, so I'm going to say instead of x minus 1, I'll write out negative 1 minus 1. Times, instead of x plus 3, I'll say negative 1 plus 3. And then just start to simplify. Negative 1 minus 1 is negative 2. Negative 1 plus 3 is 2. So my y-intercept, or my y value along my line of symmetry is negative 4. So that tells me that my entire vertex is this with this. And that's going to be at negative 1, negative 4. And then I'll just go and plot that point. Go to negative 1 and then down 4. Back to block. And there's my vertex. And for my students, I've really stressed that from the vertex, you're going up 1 over 1, up 3 over 1. So it's in this pattern, 1 over 1, 3 over 1, 5 over 1. So I can really even get another coordinate from this point and go up 5 over 1 and kind of create more of a full quadratic. So my x-intercepts, we already found those to be at x equals negative, no, that was negative 3. Hold on. X equals negative 3 and x equals 1. And now my y-intercept. That will be the last piece that we have to find. Now I could connect this, try to make this kind of nice, but can't really see past my hand. That's pretty good shape. And then I'll just put arrows in the end. My y-intercept, well, that is when x equals 0. So I'm going to say y equals 0 minus 1. So all I'm doing is substituting 0 in where you see x, and then times 0 plus 3. So y equals 0 minus 1 is negative 1. 0 plus 3 is 3. So y equals negative 3. There's my y-intercept. Equals negative 3. And that tells me my quadratic was a little bit too steep right here. So it actually, right there. Okay, so let's try one more. The only difference with this is that now we have a dilation of 1/2 instead of a normal growth rate. So it's going to be growing half as fast. The starting point is still the same. We're going to take our factored form, or the portion of this which is in factored form, x minus 2, set it equal to 0 in order to solve for our first x-intercept. And then x minus 6 equal to 0. Add 2 to both sides of the first binomial, and we'll have x equals 2. That is your first x-intercept, x equals 2, and we can plot it here. Next one, x minus 6 equals 0. Add 6 to both sides, and we'll have x equals 6. Perfect. All right, so we're gonna plot that here. X equals 2 and X equals 6. Just like the last one, in between those should be your line of symmetry. So my line of symmetry is going down through X equals 4, and I'm gonna put that in here. Remember that your line of symmetry is also the place where your vertex will lie. So I'm gonna substitute 4 into my entire original equation to find what is the y portion of my vertex, already knowing that the first part is gonna be 4, comma, something else. So y equals 1/2 times 4 minus 2 times 4 minus 6. Simplify in parentheses first. 4 minus 2 is 2. 4 minus 6 is -2. These two together, 2 times -2 is -4, and then take half of that, okay? Half of -4 is -2. So the remaining part of my vertex is -2. Go ahead and plot that point. Go over 4 and down 2, there's my vertex. Now I know my normal growth rate is 1/1, 3/1, 5/1, but if it's growing half as fast, then it's really now going to be 0.5/1. Half of 3 is 1.5/1, 2.5 instead of 5/1. So from my vertex, I'm going to go up 1/2 and over 1. Gets kind of weird here. Up 1/2 and then back 1. Then up 1.5. Well, going up 1.5 brings me up to my X-intercepts. From there, I'm going up 2.5 over 1. Up 2.5 and back 1. And that's enough information to get the shape of your quadratic. Okay? Last piece I need is my Y-intercept. So your Y-intercept occurs when X hasn't gone side to side at all. So when X equals 0. All I need to do now is substitute 0 in for X in my original equation, and then I'll have all my information. Okay, so on number 2, the last thing that we have to do is find the Y-intercept. So I'm gonna find the Y-intercept by plugging in 0 into my equation. So I'll have Y equals 1/2 times 0 minus 2 times 0 minus 6. Okay. Oops, more from before. 0 minus 2 is -2. 0 minus 6 is -6. 1/2 times that. So 1/2 times -2 times -6 is 12. Half of 12 is 6. So my Y-intercept is Y equals 6, which is going to be up, let's see, 2, 4, 6, right here, which goes in line with the growth rate that I had originally sketched in. Okay, so if you're following along with me in your pocket, we're on page 72 now. You have one more problem to try, and then I'm gonna have you try some practice on your own, pages 90 to 91. So we have one more. Now I can see that it's negative, which means my A value is -1. But still that process is going to be the same for solving for the intercepts. -x, set that equal to 0. X plus 4, set that equal to 0 and solve for your intercepts. This is like -1 equals 0, so technically I'm dividing by -1, but it's still gonna be X equals 0 as my first X-intercept. My next one, I'm gonna subtract 4 on both sides. X equals -4. So plot those 2 points. X equals 0, X equals -4. Whoa, it's hard to look at. So 0 and then -4. Right in between those two is my line of symmetry. So going down the middle at X equals -2. I already know that my vertex has to be -2, comma, something else. So I'm gonna substitute that in for substitute that in for my vertex. Y equals negative. Now it's a -2 times -2 plus 4. Negative negative 2 is a positive 2. Negative 2 plus 4 is also a positive 2, which means my vertex, the y part of my vertex, is at 4. So negative 2, 4. Go ahead and plot that point. Negative 2, positive 4, which makes sense because we already knew it being negative would have to open down. Now, your growth rate is normally 1 over 1, 3 over 1, 5 over 1. All you need to do is multiply each of them by negative 1, and then you'll have your new growth rate. So it's negative 1 over 1, negative 3 over 1, negative 5 over 1. From your vertex, go down 1 over 1, put a dot, down 1 back, put a dot. Down 3 over 1, there's your X-intercepts. From there, we can go down 5 over 1, put a dot. From here, down 5, back 1, put a dot. And you have a nice quadratic shape. Okay, so the last thing I need to find, well, I've actually already found my Y-intercept, but let's just try it one more time. When you're finding your Y-intercept, you're finding when does X equal 0. So for my Y-intercept, I'm going to substitute 0 into the equation, the original equation. So Y equals negative 0. I don't technically need that, but I'm just going to plug it in exactly how I see it. And then 0 plus 4. Negative 0 is 0. 0 times 4, it doesn't matter. 0 times anything is going to give me 0. So my Y-intercept is Y equals 0, which we already had there. Okay? So hopefully this was helpful. If you found it to be helpful, remember to like it and subscribe. Rachel Teaches Math, and have a good day.